So what we'll try, try to discuss now is that what is the meaning of this phrase? Force is equal to rate of change of momentum. Yeah. So
Yes.
to understand this, we'll first understand the definition of momentum. Then we'll understand the definition of force. And then we'll understand how this expression is derived. So, one definition that we will require is before we have done that, that acceleration is rate of change of velocity. Are we aware of this?
Yes, sir.
Okay. Now we understand that u is initial velocity, v is final velocity. This is a symbol of delta, and usually this signifies change. So delta v implies the change in velocity, and delta t implies the time in which this was brought about. Have you understood?
Yes, sir.
And in physics, whenever you see the denominator as delta t, it will always be a rate of change. Have you understood what I said? Chris, have you understood what I said?
Yes, sir.
So, for example, if I say that force is rate of change of momentum, then there will be a delta t in the denominator. If I say that acceleration is rate of change of velocity, then there will be a delta t, the change in time, the time interval. This is called the time interval in the denominator. Are we clear till here?
Yes, sir.
Okay. So definition of force is simple. Force is written as mass into acceleration. We know that mass has mk as unit of kg, acceleration has mk as units of meter per second square, and this kg meter per second square is given a special name. It is signified by Newton. Are we clear till here?
Yes, sir.
Now, one thing that you need to understand is that any unit which is in the name of a scientist, so the abbreviation is written in capital. But when you write Newton, this n should be in small. Have you understood?
Yes, sir.
Yeah. Now there is another way in which, see, this is called the SI unit. There is another unit which is called a CGS. CGS implies centimeter, grams, and second. Have you understood? So the CGS unit usually they don't ask any question. Usually I haven't seen any question be asked on CGS in IGCSE. But you may need to understand this when maybe in class 11th if you take science again, if you take physics also. So the another unit which is used instead of Newton in CGS system is Dan. Dan. This is just for your common knowledge now. So because force is equal to mass into acceleration, so Dan would be equal to gram into centimeter per second square. Is it clear, Chris?
Yes, sir.
And just for your reference, just remember that 1 Newton is equal to 10 raised to the power 5 Dal. This is just for your reference. Are we clear till
Yes.
here?
Yes, sir.
So this is a small discussion about force. Force is a vector quantity we have already discussed in scalar and the vector. Now let us see uh, the definition of momentum. So momentum, linear momentum of a body is a product of the mass and velocity. So now momentum is signified by p, small p, and it is a vector quantity, and its formula is mass into velocity. Any doubt till here?
No, sir.
So jacket उतार लो, वो नीचे ना. So mass is kg and velocity is meter per second. So the unit of momentum would be kg meter per second. Any doubt till here?
No, sir.
Okay. Then let us understand that there is something called change in momentum. So change in momentum would be given by delta p. Delta p implies the initial momentum, the final momentum, the difference between the final momentum and the initial momentum. So change in momentum would be final momentum minus initial momentum. The final momentum would be mass into final velocity. Initial momentum would be mass into initial velocity. M is common, so I can write this as m v minus u, and v minus u can be written as delta v. Chris, are we clear till here?
Yes, sir.
See, this pf and pi. This is a subscript. This implies final momentum. This implies initial
Initial
momentum.
momentum.
Yeah. And one thing that you need to understand is that in our common life, in the our common lives, the mass usually won't change. So that is why the mass is constant and it is taken
Yes.
out of the bracket, and there is v minus u only. So what
Yes.
we have understood is that the change in momentum is equal to mass v minus u. Are we clear till here, Chris?
Yes, sir.
Now, if I want to find the rate of change of momentum, I'll have to divide this by delta t. So this would be equal to m v minus u whole upon delta t. This would be m delta v upon delta t. And I'm aware that delta v upon delta t is my acceleration. So the left hand side is the rate of change of momentum, and I see that this is equal to mass into acceleration, which is force. Therefore, therefore, the relation that we have derived is that force is rate of change of momentum. Mr. Chris, are we clear about this?
Yes, sir.
This is what we wanted, that from where this relation has come, that force is equal to a rate of change of momentum. I'll repeat, whenever you see a rate of change, whenever you see rate in physics, you will always have a delta t, the time interval in the denominator. Are we clear?
Yes, sir.
Okay. So, okay. So this is the thing that we wanted, and I'll send you a few questions regarding momentum and the relation between mass, velocity, and acceleration. You'll have to do that as homework. Would you be able to do that?
Yes, sir.
Basically, I'll be sending you the questions, these numericals from question number 1 to question number 14. Very small examples, very small numericals. The answers are also given, and they won't be tough. We'll just to practice the whatever we have discussed now. Would you be able to do
Yes,
that?
sir.
Would you be able
Yes,
to?
sir.